Hello everyone, welcome to my channel. So if you're new here, I will be doing past papers, topic questions, and overall revision related to IGCSE Physics. So if you take IGCSE Physics and you wanted to boost your grades, make sure to like and subscribe for more upcoming content. So today I will be doing IGCSE Paper 4 for the new May June 2023 series. So let's start with the question 1. Question 1. Figure 1.1 shows a straight section of a river where the water is flowing from the right to the left at a speed of 0.54 meters per second. So the water is flowing from the right to the left, meaning this direction. A swimmer starts at point P and swims at a constant speed of 0.72 meters per second relative to the water and at right angle to the current. Now this right angle is very important. So the current is this from the right to the left, and the swimmer is swimming upwards, and it's at right angles. Determine relative to the river bank both the magnitude and the direction of the swimmer's velocity. So to determine the swimmer's magnitude, what we're going to do is, we know that they are at right angles, so we can draw a right angle triangle. So the swimmer, this is going to be the swimmer swimming upwards, and we have the river current, which is towards the left, and then that means the resultant force is going to be this direction, diagonally upwards to this direction. So the resultant force is going to be this direction. So this is 0.72, and then this one is 0.54. So now we have to find the magnitude of the resultant velocity. So what we do is we use Pythagoras theorem. So a squared plus b squared is equal to c squared. So we can do 0.54 squared plus 0.72 squared is equal to c squared. So this would be equal to 0.54 squared plus 0.72 squared. That would be equal to 0.81 equals to c squared. So now we square root both sides to find c. That would give us 0.9. So the magnitude of the velocity is 0.9 meters per second. And then next we're asked to find the direction. Now the direction we're asked to find is relative to the riverbank, as mentioned in the question. So that means we have to find this angle between the resultant velocity and the riverbank. So we have to find this angle. So to find this angle, we can use the trigonometric ratios. So we have the opposite side, which is 0.72, and the adjacent one 0.54. So we know that tan theta is equals to 0.72, which is opposite, over the adjacent, which is 0.54. Now 0.72 over 0.54 would give 1.3. Now we find the tan of that, which is 53.1 degrees. So the direction of velocity relative to the riverbank is 53.1 degrees. And then that's how you can get the full 4 marks. 2. After 1.5 minutes, the swimmer reaches point Q. Calculate the distance between point P and point Q. Now let's go back to the diagram. Okay, point Q is not mentioned in the diagram. So we have the speed, the resultant velocity, which is 0.9. So let's try over here, 0.9. And we have the time. So time is 1.5 minutes. But then we have to convert that into seconds. To do that, we do 1.5 times 60. So time is 90 seconds. So now the formula for speed is speed equals to distance over time. We can rearrange this formula to find distance is equals to velocity times time. So we do 0.9 times 90. 0.9 times 90 is equals to 81. So the distance is 81 meters. Next part, B. When the swimmer is crossing the river, his action produced a constant forward force on his body. Explain why he moves at a constant speed. So the answer could for that could be that, okay, if the swimmer is moving upwards, that means there is a resistive force of the water which is acting downwards. So the resistive force is going to be downwards. So that resistive force which is acting downwards would balance the upward motion of the swimmer, and there would be no resultant force. So to write that, we can do the resistive force of the water balances the motion of the swimmer. Now that would give us 1 mark, and for the second mark we can write, so there's no resultant force. Resultant force. Sorry. That's going to be our answer for the 2 marks. Let's move on to the next question. Number 2. Figure 2.1 shows a motorcyclist accelerating along a straight line, a straight horizontal section of a track. The motorcyclist and motorcycle have a combined mass of 240 kilograms. On the straight horizontal section of the track, the motorcyclist accelerates from the rest at 7.2 meters per second squared. The motorcyclist reaches the end of the straight track section of the track in 5.3 seconds. Calculate the speed of the motorcyclist at the end of the straight section. So we know that acceleration is the final speed minus the initial speed over the time. So we're given the acceleration, which is 7.2, and then we're not given the final speed. That's what we're supposed to find. And for the initial speed, we're told that it accelerates from rest, so that means the initial speed is going to be 0 minus 0 over the time, which is 5.3 seconds. So we can cross multiply. So v is going to be equals to the acceleration times the time, which is going to be 7.2 times 5.3, which gives 38.2 meters per second. That's going to be our final answer. The next question. Calculate the resultant force on the motorcyclist and motorcycle on a straight section of the track. So force is equals to mass times acceleration, and we have the mass, which is 240 kgs, and then the acceleration, which is 7.2. So we just multiply them. So 240 times 7.2 would give 1728 28 newtons. Now don't forget to write the units. B. At the end of the straight section, the track remains horizontal but bends to the right. It bends to the right, as shown in figure 2.1. When the motorcyclist reaches the bend, he travels around the bend in a circular path at a constant speed. Velocity, the vector quantity. Show how a vector quantity differs from a scalar quantity. So this is pretty simple. Vector quantities have magnitude and directions, but scalar quantities do not have direction. So vectors have directions, but scalars don't. That's a simple explanation. Describe what happens to the velocity of the motorcyclist as he travels around the bend at a constant speed. So the velocity changes. Even though the speed does not change, the velocity changes because velocity depends both on the magnitude and on the direction. So when the motorcyclist bends, the velocity is going to change, but the speed is not going to change because speed does not depend on direction. So the simple explanation would be it changes. Next question. Explain why there must be a resultant force on the motorcyclist as he travels around the bend. So the explanation could be that there is a resultant force present because there is a change in velocity. So there is a change in velocity. If there was no resultant force, there wouldn't be any change in velocity. And the second point could be there is a change in acceleration because acceleration is the change in velocity per unit time. So there is a change in acceleration too. So that's the 2 points we needed. Number 3. A rubber balloon is inflated with helium and sealed so that no helium escapes. The balloon is positioned immediately below the ceiling in a room. Heaters are switched on and the temperature of the air in the room increases. When the heaters are first switched on, the temperature of the air immediately below the ceiling increases more quickly than the temperature of the air in the rest of the room. Explain why this happens. So in this question, we're told that the temperature immediately below the ceiling increases more quickly. So that is because the temperature, the hot air is less dense than warm air. So hot air is less dense, so the hot air rises up to the top first. So the hot air rises to the top. That's the explanation. And then after that, after hot air is accumulated at the top, then the air below the hot air would also start getting hot. B. The temperature of the helium in the balloon increases, and as the rubber stretches, the volume occupied by the helium increases. State what happens to the motion of helium particles as the temperature increases. So, as the temperature increases, their speed also increases because they will gain more kinetic energy. So we can write speed increases. Next question. As the rubber stretches and the volume of the helium increases, the pressure of the helium remains constant. Explain in terms of the particles of helium how the pressure of the helium remains constant. So in this question they told us that the volume of helium increases and so does the temperature, but the pressure remains constant. So what happens is, here is the balloon, and then there are particles, helium particles present, and And then when when the temperature is increased, they start moving faster, and they hit the walls harder with greater force. But then when the volume increases, the helium particles would hit the walls less. So there would be less density, and then they would hit the walls less because there's more space. So these two effects cancel out each other. So we can write it as this. The first point could be the particles will hit the walls harder. Walls harder. And then the next explanation could be the particles collide less frequently. Right? Less frequently because there is larger volume. So due to the larger volume, they can collide less frequently because they're less dense, they're more spaced out. And then the two effects cancel out each other. So the pressure remains the same. Number 4. A student investigates the efficiency of a filament lamp. Figure 4.1 shows the filament lamp with its glass bulb immersed in water in a beaker. The reading on the thermometer is the water is 19 degrees Celsius. Only the glass of the lamp is in contact with the water, and the electrical connections are completely insulated. So there's no wastage of energy, or there's no heat coming out. The lamp is switched on. At the end of the experiment, the temperature of the water is 21.5 degrees Celsius. The mass of the water in the beaker is 600 grams, and the specific heat capacity of water is 4,200 joule per kilogram degree Celsius. State that the increase in the internal energy show that the increase in the internal energy of the water is 6,300 joules. So the formula is Q, which is the energy, is equals to the mass times specific heat capacity times the change in temperature. So the mass is 600 grams, but we have to convert it into kilograms, so it's going to be 0.6 kilograms times the specific heat capacity is 4,200 times the change in temperature. So the initial temperature was 19 degrees Celsius, the final was 21.5. So we do 21.5 minus 19. Now that would be equal to 2.5. Now we can multiply all these to find the energy. So 0.6 times 4,200 times 2.5, which would give 6,300. So this is equal to this one. So we have proved it. Next question. In the experiment, the lamp switched on for 500 seconds. The power supplied to the filament lamp is 13 watts. The useful energy from the lamp is transferred as light. The energy that increased the temperature of the water is wasted energy. Determine the maximum possible efficiency of the lamp. So if the total power supplied was 13 watts and it was switched on for 500 seconds, we can calculate the energy. So we know that power is equals to energy over time. If we rearrange this formula, energy would be power times time. So the energy would be 13 times 500, which would give 6,500. So this was the total amount of energy supplied, and the energy wasted was 6,300. So if we subtract 6,300 from this, we would get the useful energy, which is 200. So 200 watts, 200 joules is the total amount of energy used to light the lamp, the useful energy. So efficiency is the useful energy, 200, over the total energy, which is 6,500. Then times 100. Now this would give us 3.1%. So maximum possible efficiency is 3.1%. So the lamp is not pretty efficient. The efficiency of the lamp is less than the value determined on the previous question, so it's less than 3.1. Suggest one reason for this. So one of the explanation could be that the temperature could be, the thermal energy could be transferred from the water to the beaker and then to the bench the beaker is standing on, so it's unpredictable. So we can write the thermal energy is transferred to the beaker and then to the bench. That's our answer. There could also be other multiple explanations for this. Number 5. Figure 5.1 shows a block ABCD made from glass, and that has a refractive index of 1.5. The block has one curved side AB, so this is the curved side AB, and three straight lines BC, CD, and DA. So this is a diagram. There are right angles at C and D. The curved side AB is 1/4 of the circumference of a circle that has its center at point P. So this is point P, and then this quarter circle is 1/4 of a full circle with a center of P. So this quarter circle is part of a circle with a center P. A ray of monochromatic light enters the block through the curved side AB and strikes side BC at P. So it strikes side BC at P, right at the center. Some light emerges into the air and some light is reflected. State what's meant by monochromatic. So monochromatic is a type of light that only has a single wavelength. So light that has single wavelength. So due to the single wavelengths, it would have a single color. B. Explain why the ray of light does not change direction when it enters the block through the side AB, so through the curved side. So one of the reasons for that could be that the line is moving along the normal line. So it's moving along the normal. So there would not be any refraction of light. So there's no refraction of light. That's the answer. So that the critical angle C for the glass on refractive index 1.5 is 42. So the formula for refractive index with critical angle is 1 over sine C. So we have the refractive index, which is 1.5, is equals to 1 over sine C. So we can do cross multiplication. So 1.5 times sine c is equals to 1. So we can divide both sides by 1.5 to isolate sine c. So 1 over 1.5, that would be 0.666. And then we can do shift sign on our calculator to find that, and then it would be 41.8, which is approximately equal to 42 degrees. So that's how we find the critical angle. D. Figure 5.1 shows that the angle between the ray of light and line AP is theta, where the line AP is at right angles to side BC. Angle theta increases to 45 degrees. State and explain what happens to the light that strikes P. So if angle theta increases to 45 degrees, that means it has exceeded the refractive index, which was 42 degrees. So the explanation could be, so if the incident ray surpasses the critical angle, that means there would be total internal reflection. Be a total internal reflection. That is because the angle of incident, so I, was greater than the critical angle. That's our answer. When theta equals 45 degrees, the reflected light hits side CD. Describe what happens when this reflected light strikes side CD. So let's go back to the diagram. So we can see that this light, the reflected light, hits side CD. So if it's hit side CD, this is going to act like a mirror, and it's going to be reflected. So all the light is going to be reflected back. So we can write all the light is reflected. All the light is reflected. Let's move on to the next question. Number 6. A mobile phone network uses microwaves of frequency 1.9 times 10 to the power of 9 Hz to transmit and receive signals. The speed of microwaves in air is 3.0 times 10 to the power of 8 meters per second. Calculate the wavelengths of these microwaves in air. So we know that the speed is equals to the frequency times the wavelength. So we can rearrange this formula to find the wavelength is going to be over f over f. So the wavelength is the speed over frequency. So it's going to be 3 times 10 to the power of 8 over 1.9 times 10 to the power of 9. So when we divide this 2, we are going to get 0.16. So that's going to be our wavelength, 0.16 meters. State 2 reasons why microwaves are used for mobile phone or cell phone signals. One of the reasons could be that there is going to be faster data transmission. So we can write faster data transmission. And then the other could be that they can be sent over long distances, so they can travel long distances. They can travel long distances. C. A mobile phone network uses digital signals to communicate with the phone. Describe with aid of a diagram how a digital signal differ from an analog signal. So first let's draw the diagram to make it easier. So a digital signal has only two values, 0 or 1, off and on, true or false. So the value would be somewhere like this. If we can graph it, and it would be something like this. So this is the first value, and then it would be off. They would have equal lengths, and then we would have off, and then this is on. So this is roughly the diagram for a digital signal. But for an analog signal, it differs. It has different intermediate values. So it has different variable values. So it could be something like this. So it could be something like this. So we can write it as digital signals have different values. No, they only have two values. Have only two values. But analog signals have variable values. So that's the difference. State two advantage of using digital signals rather than analog signals. So when we are using digital signals, they can travel long distances without having an error. They can travel long distances. And the next one could be that they have fast data transmission. They have fast data transmission. That's the advantage of digital signals over analog signals. Number 7. Figure 7.1 shows a circuit that contains a battery, a switch, a voltmeter, and 3 40 ohms resistors, R1, R2, and R3. The switch is open and resistors R1 and R2 form a potential divider. Describe what is meant by a potential divider. A potential divider is like an arrangement of circuits which is used to share the voltage between resistors, and this voltage depends on the magnitude of the resistance. So it's going to be in proportion to the resistors. So a 40 ohm resistor would get more voltage than a 20 ohm resistor. So we can write it as it divides, or in other ways we can write shares the voltage in proportion to the resistors. You can write it like that. B. The reading on the voltmeter is 7.5. Calculate the electromotive force of the battery. So to calculate the electromotive force, what we do is we have this voltmeter over here, and it reads 7.5, and it's across one of the resistors. So this potential divider would count for one of the resistors at one time, not both at the same time. So what we can do is this over here we have 7.5 volts, and then over here we also have 7.5 volts. So the total amount of voltage which is produced from the power supply is going to be 7.5 plus 7.5, giving 15 volts. So that's going to be our answer. The switch is closed. Calculate the resistance of the complete circuit. So on the when you go back to the diagram, we can see that R3 and R2 are in parallel. So first let's calculate the resistance of that. So they're all 40 ohms. So when they are in parallel, what we do is R2 times R3 over R2 plus R3. So since they're both 40 ohms, we can do 40 ohms squared over 80 ohms, which is their sum. So 40 squared divided by 80, which gives 20. So we have 20 ohms. But then we're not done yet, because now the total resistance is 20 ohms. But over here, we have another resistor which is in series, which is 40 ohms. So we just have to add them. So 40 plus 20 would give us 60 ohms. So the total resistance would be 60 ohms. Because to the 20 ohms we have added the 40 ohms resistor, which is connected in series. C. Calculate the reading of the voltmeter when the switch is closed. So when the switch is closed, that means we would account for both the resistors. So previously when the switch was opened, it was divided equally between the two resistors. But then when the switch is closed, that means the resistors are in parallel. So the total resistance would be 20 ohms. So it's going to be, so the total 15 volts is going to be divided in equal ratios. So what we do is, since they are in proportion, what we're going to do is we have the 15 volts is for the 60 ohms, which is the total resistance. So that means X would be for the 40 ohms. So we can cross multiply. So it's going to be 15 times 40 over 60. So 15 times 40 over 60, which gives us 10. So it's going to be 10 ohms. So in the voltmeter, we know that this voltmeter is going to get 10 ohms. 10 ohms, and this one is going to get 5 ohms. Because this resistance is 40 and this is 20, so we're gonna share the voltage in proportion to the resistance. Number 8. The electricity supplied to a town is transmitted using a high voltage cable. A transformer in the town has a soft iron core. Explain the principal operation of a simple iron core transformer. So in a transformer, what happens first is an AC current would be passed through the primary coil. So AC is passed through the primary coil. And then it would produce an alternating current, an alternating magnetic field. It would produce an AC magnetic field. And then after that, this alternating magnetic field would cut the secondary coil. So which would cut cut the secondary coil, which would be cut. So the alternating magnetic field would be cut by the secondary coil. So it would be cut by the secondary coil, and then it would produce AC current on the secondary coil. So an AC current would be produced. So let me explain this in a diagram so it would be easier. So we have a transformer over here. This is the soft iron core, and then we have our primary coil, and then we have our secondary coil. Now AC current would be provided over here. So there would be AC power supply, which would be provided over here. So the AC current would produce an alternating magnetic field in the iron core. So when the iron core the AC magnetic field would be cut by the secondary coil. And when a magnetic field is cut by a secondary coil, a current is induced. So over here, there is an AC current which would be induced. So there's going to be an AC output. So this is a basic working principle of a transformer. Number B. The transformer steps the supply voltage down from 220,000 volts to 33,000 volts. There are 450 turns on the secondary coil. Calculate the number of turns on the primary coil. So the formula is NP over VP is equals to NS over VS. So NP represents the turns in the primary coil, VP represents the voltage in the primary coil, and then NS represents the secondary coil, the number of turns, and VS represents the voltage in the secondary coil. So we just plug in the values. So we don't have NP. VP is 220,000. And then NS is 450. And then VS is 33,000. So we can rearrange the formula. So it's going to be 450 times 220,000 over 33,000. So that would ultimately give us 3,000 as the number of turns. So the number of turns in the primary coil is going to be 3,000. The electrical power transferred to the transformer by the high voltage cable is 77 megawatt. Calculate the current in the primary coil. So we know that power is voltage times current. So we're asked to find the current in the primary coil. So the voltage in the primary coil is 220,000. So power is equal to 220,000 times I. So we have 77 megawatts. So 77 megawatts is equal to 77 million watts. So we can write it in standard form, 7.7 times 10 to the power of 7, and then we divide it by 220,000 to find the current. So this would give us 350 amps. So the current is going to be 350. That's going to be our final answer. Number 9. Figure 9.1 represents all the particles in a neutral atom of radioactive isotope X1. Determine the number of neutrons in this atom and explain how the answer is obtained. So the number of neutrons is, to find the number of neutrons, what we do is first we have to find the number of electrons. So we have 1, 2, 3, 4, 5. So we have 5 electrons. So this is a neutral atom. So that means they also have 5. The number of protons is going to be 5. So this is a nucleus that represents the number of neutrons plus protons. So protons is going to be 5. So the nucleus is going to have n number of neutrons and then 5 protons. So let's count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 particles. So if we had 5 protons, so we would subtract 5, and then we would have 7 neutrons. The number of neutrons would be 7. So for the explanation, we can put this over here. B. The isotope X1 is a beta emitter that decays to a stable isotope X2. Describe how the nucleus of X2 differs from the nucleus of X1. So we know that in a beta emission, a neutron would become electron and a proton. So during a beta emission, the isotope X1 would lose a neutron, but then it would lose a neutron, but then X2 will have less neutron, but it would have one more proton. So we can write it as so it would have so it would have one more proton. We're talking about isotope X2, and one less neutron. So this is our answer. Suggest why isotope X2 is stable whereas X1 is not stable. So the reason for that could be that X2 has less number of neutrons because it has lost one neutron. So the answer could be it has less number of neutrons. C. The half-life of X1 is approximately 20 milliseconds. Define the term half-life. So half-life is basically the time taken for a nuclei to half. So it's the time taken for a nucleus. Let me spell nucleus. Yes, to half or for the mass to be half than the first one. So just one reason why isotopes with very short lives are especially hazardous, because when they have very short half-lives, that means they would emit radioactive particles more quickly, so that could be dangerous. So in a short time, they would produce large amount of radioactive particles. So they would produce large amount of radioactive particles. Number 10. I think this is the last question, and it's about space. Pluto is a dwarf planet. Figure 10.1 shows the direction of motion of Pluto as it follows its elliptical orbit around the Sun. So this is Pluto over here, and it's moving anti-clockwise around the Sun. Point X is the point in orbit closest to the Sun, and point Y is the furthest away. The orbital speed of Pluto varies as it orbits the Sun. Describe how the speed of Pluto varies as it moves from X to Y and then back to X. So as Pluto is moving from point X to point Y, the speed is going to decrease because it's moving farther away from the Sun. So that means the kinetic energy would decrease, so the speed decreases. You know what? But as Pluto is moving from point Y to point X, the speed is gonna increase because as it's moving closer to the Sun, so there would be more kinetic energy. So we can write from X to Y, the speed decreases, and from Y to X it increases. The next question, explain in terms of energy transfers why the speed of Pluto varies in this way. So I've explained it previously. So as it's moving from X to Y, the speed increases because it gains kinetic energy. I mean, it loses kinetic energy. From X to Y, it loses kinetic energy, and it would gain GPE, or gravitational potential energy. So from X to Y, it loses kinetic energy, and gains gravitational potential energy. So the loss in kinetic energy will result in decreasing the speed, in the reduced speed. And then we know that the highest GPE is located at Y, and the highest kinetic energy is located at X. So we can write that. So highest GPE is going to be at Y, and lowest KE, or kinetic energy, is going to be at Y, because when the kinetic energy increases, the gravitational potential energy decreases, so it's vice versa. B. The average temperature on the surface of Pluto is 43 Kelvin. Convert this temperature into degrees Celsius. So to convert it into degrees Celsius, what we do is we subtract 273. So it's going to be 43 minus 273, which gives us negative 230. Pluto has a white surface as shown in figure 10.2. As Pluto rotates, the white surface alternatively faces towards and away from the Sun. Explain how this affects the temperature of Pluto as it rotates on its own axis. So we know that a white surface is a poor absorber of radiation. So when the white surface is facing the Sun, if the Sun is over here, even though the Sun is not smaller than Pluto, but if the Sun was over here and it's facing the white surface is a poor absorber of radiation. So that means when the white surface is facing the Sun, there would be less increase in temperature. So we can write when the white surface is facing the Sun, there will be less increase in temperature. Less increase in temperature because white surface is a poor absorber of radiation. It's poor absorber of radiation. That's going to be our answer. That was our final question. So if you enjoyed, make sure to like and subscribe, and if you have any comments or suggestions, make sure to write them down below. And thank you for watching.